Last lesson of the unit, solving trig equations, where you might need to use identities. Do you have to use identities? Not always. Sine of 2 theta, we did that yesterday. Right? So you just found all the angles that give you, in this case, a sine ratio of 0. Found them, divide all of them by 2. But on your formula sheet, you also have an identity for sine of 2 alpha, which is 2 sine alpha cos alpha. So in this case, I could replace this with 2 sine theta cos theta on the left side. Okay? So we already know how to solve this a different way. Now we're using identities. Solving that, I'm going to go sides by 2. You cannot get just one trig ratio by itself. Okay? But remember, this is a product. All of these, those other ones that we were doing today, when we factored, we let each factor equal 0. This is a factor. So your 2 factors equal to 0. Okay. So, what are we doing this? All real numbers in radians, so general solutions. So I start writing out the first few. So when do you get a sine ratio of 0? Well, sine, you get a 0 at 0. Radians pi, 2 pi, etc. For cos, when do you get 0? That's at pi over 2, 3 pi over 2, etc. Okay, so what does that look like? Maybe we can simplify our general solutions. So 0, pi, 2 pi, etc. So these. Pi over 2, 3 pi over 2. So those are quadrantal angles. So every pi over 2. So we only need one statement for this. So theta equals multiples of pi over 2. Much easier than going multiples of pi, pi over 2 plus multiples of pi separately. It simplifies to this. Yep.
Theta is less than x is greater than 2.
That should be a 0.
Less than 1 equals 2. Okay, yeah, that's what I thought.
It's just a typo. Okay, anytime you see some squares, take a look at your formula sheet. Cos squared minus sine squared. Halfway down, actually 3/4 of the way down, you'll see cos squared alpha minus sine squared alpha equals cos of 2 alpha. So in this case, I'm actually going to go back to a cos of 2 alpha and solve it like we did yesterday. Whereas in the first one, I went from cos of 2 theta, used an identity to get it down into just theta. Okay? So sometimes you might go either way. Sorry, you went 1 minus sine squared? Yeah, you can do it. Absolutely. Yeah.
Yeah, that would be the same answer.
Okay, noise. Do math without talking. Okay, where's cos 0? Cos 0 is here and here. Right, so 2x. We're dealing in, so remember what we did yesterday? We found what interval for 2x. So that would be between 0 and 4 pi. So the angles that give us a cos of 0 between 0 and 4 pi are pi over 2, 3 pi over 2, then plus 2 pi. So that's 5 pi over 2, and 7 pi over 2. So then divide everything by 2, both sides. So we get pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So that's between 0 and 2 pi. Didn't ask for the general solution, but what would a nice simplified general solution be for that? Okay, is that, you know what it is? N pi. Even smaller than N pi. Yeah. Okay, because here, you're adding here 2 pi over 4, which is pi over 2. Here, you're adding 2 pi over 4, which is pi over 2. 2 pi over 4, which is pi over 2. So this actually, as a general solution, just so you know, is equal to pi over 4 plus n pi over 2. Didn't ask you for that, but it's good to practice, right?
Right, well, that makes sense because if the value is 2 and the period is 1/2. Yeah.
You get 2 cycles. Right? Then 4 in 0 to 2.
Yeah.
Okay, C. Take a look at your formula sheet. 1 plus, you got some squares, right? So look at formula sheet 1 plus tan squared equals secant squared. It's right on there. So replace just one of them. Don't replace the tan squared to secant and then secant squared to tan. You're going back and forth. You'll never get there. So 1 plus tan squared is secant squared. Now isolate the secant squared. Then take the square root of both sides, and then if you want to, I convert it back to cos. Up to you. Remember, 1 over root 2 is the same as root 2 over 2. So this you can get exact values. We only need degrees in this case, and again between 0 and 360. You don't need a general solution. being in every quadrant because it's positive and negative. And where does cos give you a root 2 over 2 value? At 45 degrees, exactly. So there, 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 there. Sorry. You can see. This is an X. So 45, 135, 225, and 3. What's the difference between all of those? 9 degrees. So if you had to do a general statement, it would be 45 degrees plus multiples of 90 degrees. We're going. What are you doing? Face forward. I'm up here. Hello. Hi. Please pretend that you're listening. Okay, next one. What do you do with that? Like, there's no squares.
Multiply both sides by sine x. That's what I did.
Yep. Because remember, cosecant x, get that down in terms of sine. It's 1 over sine. Okay, so first step here for me, I'm going to show it like this. And then multiply through by sine x. And then you got to bring everything to one side and factor. Don't you guys find this kind of fun? Like all that factoring really intense.
So useful.
Okay, so this one says degrees and general solution. Remember we did one or two the other day. We got a factor where, when we solved for sine, it gave us the value that was bigger than 1. So just remember, there's not going to be a solution for that factor, if that's the case. And these do have them, but just remember, you can't have a sine value or a cosine value greater than 1.
When you're doing it.
Yeah, if you try to do it in your calculator, it will give you an error.
Unless you're in. Actually, if I put it in the imaginary mode, what would it be?
Okay, so sine is just positive. So first and second. Sine is a half. That is exact values. That's going to be 30 degrees and 150. We're only going, oh no, we're doing general. Okay, so here. Okay, so take a look at this one. This is kind of nice. So I've drawn my, looks like a happy face. We're so happy, right? So there's your two angles. That gives you a sine of 1/2, first and second quadrant. This is 270 to get you a sine of, it looks like a windmill. What's the angle between all of those? 120. So as a single statement, this is listening please. So as a single statement, it's going to be 30 plus multiples of 120. You do not have to have three separate statements. Okay? So that's why drawing a little diagram really helps, because you can see that. So these two from sine x equals 1/2, this from sine equals -1. That's simple. There's angles in the first rotation or two. And so you can see, if I didn't have this factor, then I couldn't say 30 plus 120. I would have to say 30 plus 360 equals this. 150 plus 360 equals this. And because we have this, and it fits in equally in between, we don't have to have three separate statements. Okay? Now these last two here, take a look at them. They have had, none of them have had denominators in the beginning, but they've had reciprocal trig ratios. So here, if we were thinking about restrictions, nothing in the denominator, but we know that tan theta cannot be undefined, and secant theta cannot be undefined. So what makes those undefined is when cos of theta is 0. So we do not want it to be 0. Notice how when we did our work, we got down to cos theta equals this. Cos theta did not equal 0 here. So I don't have to go any further in terms of a restriction, right? If this was my restriction, and that was my actual last part of my equation, then obviously these would be extraneous solutions that I would get, right? But this is not 0. Okay, so if it's the same trig ratio, you don't have to worry about restrictions. This one here, nothing in the denominator, but we do have the reciprocal, cosecant. So cosecant x cannot be undefined. When does that happen? When sine of x is 0, so we do not want that. We have sine of x's here, but neither of these are equal to 0. So these are not going to be any restricted values, right? If one of these ended up being sine x equals 0, then you have to eliminate it from the solution set. But as I said, it's very rare, and in this case, that's an easy way to check. You don't have to go any further than that. Okay? And then next one is tan of 2 theta. I would really solve that as we did the other day, or as we converted b here to cos, what was it? Here we converted to cos of 2x. Converting tan of 2 theta using the tan formula is actually more complicated. So I wouldn't want to make that more complicated. I would just go from here. Okay, so I find out, obviously in this case, because it's not a special angle, we'll need to use our calculator for that. So 2 theta equals I'm kind of going to call this, actually I'm going to go beta equals 2 theta, and then I'll call that the reference angle here. Just because it's negative, and I don't want to put negative into my calculator. You can, but it's not going to give me the first positive. So this is in radians, no p radian. Okay, so then second tan, 4 divided by 3. I'll go through decimal places. Okay. So then 2 theta equals, we've got to think, this is the reference angle. Tan is negative in the second and the fourth. So our reference angle is 0.9273. So this first one is going to be pi minus 0.9273, and then 2 pi minus 0.9273.
And you got one of 3 because it's 2 theta.
Right. Yeah. So we should really go 0, 2 theta, 4 pi. I'm just going to move this up a little bit. So, yeah, to get more, because really here I haven't divided by 2 yet, so I need to go to 4 pi. So then 2 pi, so here, comma, that's going to be 3 pi minus 0.9273, and then 4 pi minus 0.9273. Okay, then divide by 2. If you still have room in your calculator, you can just, that one I'm just going to divide by 2, put it here, and then round the nearest, usually nearest hundredth per radians. So,
Here it says
5.32. Then 8, this one, divided by 2. And remember, 2 pi is 2 times 3.14, so 6.28 something, so you know you're getting pretty close. You hadn't figured that new domain out. Now the last one has a secant squared, which you could replace with 1 plus tan squared, but really, like, the other trig ratio isn't tan, so it's not really going to be helpful. Secant is 1 over cos, so I think it would be better to replace secant squared with 1 over cos squared. Okay. Yep, multiply through by the denominator. you're actually going to get it cubic.
If you gave it like, if you wanted it, if you asked for the exact value of cosine x in simplified form, would we be required to convert 1 over root, or the cube root of 3 to like rationalize denominator?
If we say rationalize, yeah.
Okay.
But we want.
Yeah.
So really you multiply both sides by cos squared of x. Now, interestingly, if this had been something like 8, then that would be 8 cos cubed x. You could bring the 1 over, and it would be a difference of cubes. Right? So you could factor that, although then you would have to solve that quadratic factor using the quadratic formula with cos, which we're not going to get you to do. But in any case, in this cubic, that's not a perfect cube. You can isolate.
Actually, if it was 8 cos to the, you just divide both sides by 8, and then you can take the cube root on both sides.
Yeah, you can. You'll get the one of them, but you could also get, you're missing, I guess that would be, it would be a non-real solution.
So yeah, you're missing.
Okay, so then here, you take the cubed root. You want to get cos by itself. So cubed root, not plus or minus, because we're doing the cubed root, right? So either this or this, it's not your final answer, right? So you don't have to rationalize. You'll need your calculator. There is no special angle with that. Okay, so it is positive. So first and fourth. Okay, so your reference angle will be the inverse cos of that. So second, what are we answering here? Radians or degrees? So degrees. So mode, degree. Okay, so second cos. You can do the cubed root of 1 over 3. You can go 1 divided by. Cubed root is in math. You could go 1 divided by 3 to the 1/3. You remember back to math 10. So to the nearest degree, it's 46. And so the other one, between 0 and 360, would be 360 minus 46. So what's that? 314. Yeah, between 0 and 360. Okay. So now we are done. Trig is done. Trig is done.